Running batch simulations can greatly speed up the process of running tests on your channel simulations. This video will show you several ways to run batch simulations on your parameters for both ADS modeled and IBIS-AMI modeled components. We'll then also look at how to set up your data display to easily look through different batches simulated. Here's the channel we'll be using for all of these simulations. We'll start with an IBIS-AMI transmitter, then a VIA model through a stripline edge-coupled channel, then through another VIA model to a behavioral receiver. The IBIS-AMI and VIA models are taken from the PCI 3 test compliance bench. Currently, this schematic is set up as a channel simulation. By running a batch simulation, we can automate many runs or batches of this simulation with different parameter values. First, we'll define which parameters to run the batch simulation on. We'll sweep through the width and spacing of the channel, as well as the preshoot and deemphasis of the TX. Let's first set up the width and spacing parameters. First, place a var, then add a width variable with a default value, and spacing variable, also with a default value. We'll then set the line width and spacing of the channel to be the values from the variable. Now from the channel simulation palette, place the batch simulation controller. Inside the controller, add the variable you want to sweep, along with its start, stop, and step size. We'll also add the spacing variable and set its start and stop values. Let's take a quick look at the preshoot and deemphasis in the TX. By default, it is set to be a string with 2 values. As such, the sweep will have to be defined a little differently. From the data items palette, place a data access component. We'll add a predefined MDF file which has all the preset combinations. Taking a quick look at the file, we see that the row number is followed by the row header preset. Back in the menu, we'll change the interpolation method to be index lookup because we'll be accessing the data by its index. We'll set the access index value to be the variable tx eq preset index. We'll add to the var definitions from before. I'll add tx eq preset index starting at 0 to my list of variables. We need another variable which would take the value from the data access component. Change the mode to name equals value. Then we'll set a tx eq preset value to equal file dac1, comma, preset. We need to set the value in the TX to take the value from this last variable. Under preshoot deemphasis, change to user specified, then type in the name of the variable. Finally, we need to add this to the batch simulation. Add the index variable and sweep over the number of indices. Here's the data display after simulation. I've gone ahead and added a number of plots and formulas which will help us easily maneuver the different batches. The sweep dimensions equation tells us the number of values that were run for each of the different parameters. Each of the index equations is an array from 0 to the swept dimension minus 1, since the data is 0 indexed. I've added sliders for each of the index variables. To add these sliders, go to Insert, Slider, then go to the Equations drop-down and select the index variable. Let's take a quick look at the trace expression. Unlike the regular density plots, we see that we've defined an array to plot for the density. If we hit variable info and go to the density, we can see which variables the density plots are dependent on. In this case, it's the index of the DAG, the spacing, the width, the index, and time. The first of these three dependent variables are set by the marker values, which are the indices of each batch. Time and index for density are the point in time as well as the actual density value for the plot. If we want to plot all densities over all time, we have to specify them to be : or all possible values. When we move the sliders, we can see the response of all the graphs instantaneously. Setting up graphs with these sliders will help you evaluate the results of your batch. ADS can generate iDiagram summaries in an Excel spreadsheet. Under the Channel Sim palette, place the iSummary Report component. After you simulate, the file will be generated in the data folder of your workspace. The summary will look something like this. You can see that the variables that you ran the batch simulation on, as well as the width, height, and index for each of these runs. Let's look at two more ways to run batch simulations on your channels. Both methods will use CSV files, which can be created either in Excel or a simple text editor. First, we'll look at how to set up CSV lists. These are useful when you only want to run a sweep over a certain set of values for your parameters. Here's my CSV file. In the top row, I have a list of the variable names. Each following row is one batch to run, with each variable value defined, separated by commas. Back in the schematic, it's almost exactly the same as the previous example. The only changes are found in the batch simulation. In the batch sim controller, I've changed the mode to use sweep module. The module name is CSV list, which lists the batches to run, and the file name is found in the data folder of the workspace. Now that we've loaded the module, we can simulate through each of these batches. Again, I've set up the data display in advance, but I'll point out the differences on this data display compared to the previous one. The slider is defined by batch number. This variable is automatically generated and goes through the number of batches you ran, which is the same as the number of rows on your CSV minus 1. Since the indices for the arrays are 0 indexed, I've defined the batch index variable as m1 slider minus 1. As with each of the plots in the previous display, these plots are dependent on the batch number and other variables. The density plot, for example, is defined by the batch number and the index and time. The other CSV-based method is the sweep module. In this version of the batch simulation, each line is a variable to sweep over. The next three values are start, stop, and step size. The final column is a sweep variation type. You can specify this to be either linear or log. Back in the batch sim, there's not much to change. In the controller, you change the module to CSV sweep and select the new CSV file. These are all the changes you need to make to run the sweep module. This data display is identical to the previous example. Of course, there are more batches since a matrix of all possible sets of the values have been simulated. You can move the slider to run through the batches. Thank you for watching this Keysight ESOF EDA tutorial. You can find a link to a free trial of ADS in the video description below.